Hi there. It's really excited to be here. My first SciPy to be in the ballroom, but we'll see how this goes. So I'm John Readey. Here, let me flip to here. I joined the HDF group last year. My previous background was at Amazon.com. And one of the factors that motivated my work on HDF Server is that at Amazon, it was drilled into our heads, make everything a service. Right, so this is a Bezos dictate. And if you, say, go to Amazon.com and look up Wes's book, you won't realize it, but there are hundreds of services being invoked when that page loads. And you don't want to be the guy who adds 50 milliseconds to the latency of the load time of that page. But that's just the culture of Amazon, was to encapsulate functionality as a service rather than as a monolithic application. So many of you, I believe, are familiar with HDF5, but just a quick backgrounder. If you didn't catch Andrew Kletz's talk yesterday, it was a really good review of HDF and H5Py, so I recommend that. HDF5, you can think of it as an API, you can think of it as a file format, or a data model. But basically, it's like a file system within a file, right? So within the HDF5 file, you can have multidimensional arrays, you can have images, you can have tables, you can have groups. Groups can link to other groups. So it's highly flexible.
Your slides aren't showing up.
Oh.
You may need to mirror your display.
Oh, here. Wait, I didn't. OK, good. OK, so that's the page. OK, yeah, here's what it is. And beyond just like a file system within a file, you have features like chunking and compression and NumPy-style data selection. So you can get a hyperslab selection of a multidimensional data set and pull those bytes off the file. It has a very sophisticated type system. It's highly portable binary format, a directed graph of objects, supports various compression technologies, data slicing, reduction, attributes, so you can add metadata to your objects, and bindings for C, Fortran, Java, Python, and other languages. So why an API? Why a web API for HDF5? One motivation is to provide a reference to data via URI. Right? This means that I can give one string that references any object within a file, any hyperslab of a data set within a file via one string. And I think that's a very powerful concept. I can imagine like many IPython notebooks you see, you start with copying a file somewhere, and then the notebook runs. But imagine you could have an IPython notebook that references the data via URI, and then it would work from anywhere without any preloaded data. Network transparency, so your data can be somewhere else than where your computation is running. The clients can be lighter weight because they only bring in the whole HDF5 library. Supports multiple writer, multiple reader, right? So with the current HDF5 library, you cannot have multiple writers opening the same file at the same time. But with the server acting as an intermediary, that's entirely possible. Another cool thing, which I haven't had time to work on yet, is to have a web UI, right? Since the HDF server supports web UIs, you could have a web page with a AJAX JavaScript engine that's pulling in data and then rendering that data dynamically. Also, having it on a server adds some scope to do some performance tricks, enhancements that would be impractical to do in the context of a library. So HDF Server, it's written in Python using Tornado. It has a REST-based API, and I'll talk about that a bit later. All requests and responses are in JSON. So one of the side effects of this project is that we now have a complete JSON specification of HDF5. So any HDF5 file or component file can be translated to JSON and vice versa. Supports full create, read, update, delete. Supports most HDF5 features, component types, compression, chunking, links, external links. It's self-contained, it's web server, you don't need Apache. It's open source. Each object is identified by UUID. Quite easy to install and run. And most recently, I've created a Python client library that mimics H5Py. So here's a little facetiously my simple diagram of REST. This is actually the most complex REST API I've ever worked on because it's reflecting this fairly complex model of HDF5. So what's this REST thing all about anyway? It's client server. It's stateless, meaning that any REST operation can exist independently of whatever preceded or comes after it. Cacheable. So I can cache a response from a request, and then if the state hasn't changed, I can reuse that response. Every resource is identified by URI, right? So the URI points to a resource, a data set, a group, a link, and then you operate on that URI. There are many web APIs that are basically get wrappers around RPC, right? So that may be a practical approach, but it's not really capturing the semantics of REST. And it uses standard HTTP methods and behaviors. So we're most familiar with GET, right? Because every time you go to a browser and enter a URL, that's a GET request. But the four primary methods are GET, POST, PUT, DELETE. And they have a certain semantics. So imagine on the web, you're in an environment where your requests might just get lost in the weeds somewhere, right? So it's important to know that if I do a put, that request is idempotent, right? So if I do a put and I don't get a response, it's safe to do another put and not cause any unintended side effects. So let's kind of look at an example URI and kind of break it down to components. So here, it's a little small font, but it's basically saying I'm using HTTP to access, we call it domain, but it translates to a file in HDF5. So tall.data.hdfgroup.org would translate to the file /org/hdfgroup/data/tall.h5. The :7253 is a port the server is running on. The dataset /long UID/value identifies the resource. Okay, so if you're familiar with HDF5, you might be surprised that the dataset is not referenced as a path, right? Like /group1/group1.1/dataset1.1.1. This is because in HDF5, you can have many paths that identify the same data set. But we want to provide a canonical URI for that data set. So rather than use paths, we use dataset/UID to identify the data set. And then finally, we have a query parameter which says, don't give me all the values. I just want this 4x4 upper left corner of the data set. And note, there's no runtime context, right? So I could invoke a GET on this URI at any time, and it would return the same response. OK, so let's do some demos. I have 3 demos. First, I'm going to show the basic REST API. And then I'm going to show using the H5PyD client library. And finally, if I have time, I'll show the multiple clients talking to the server. So let me switch here. How do I get this to my screen? Can you guys see that? 1 second. Gets better. Okay, so we will import request, which is a convenience library for making HTTP and JSON. And then here we will get a representation of the domain object. Okay, so this request went out. The request http://127.0.0.0.1:5000/. And what it returns is the representation of the domain object, which basically all it has is some timestamps and a UUID of the root group of that domain. Okay, fine. So given that, let's get information about the data link in the root group. So I do this. So I do a request that says /groups / the root group UID /links /data, and it comes back with some stuff. And here it says there's a link, and that link has a data set. It's a hard link, and the UID is this. So now I can, I was going to print the dataset UID. Now, given that information, I can go out and get the representation of the dataset itself. So I do that. And now we get some information, creation properties, created, last modified, attribute count, the shape. It's a 320 by 320 dataset. The type is a unsigned, short, little Indian. Okay, good to know. And now we're actually going to get the data. Cool. So I went here and I said endpoint is /datasets /dataset UID /value, which basically says give me all the data in that dataset. It comes back. I read it as a NumPy array, and then I plot it. And it's actually an elevation map of Crater Lake. Now, suppose I want just a one portion of this data set. Let's say just this area around Wizard Island. I can do the same thing. Now add a select query parameter that says, give me this start value, this end value, this start value, this end value. And I'll come back with that. Okay. So that is the REST API. Now you might be thinking, okay, that's a little tedious. You know, not that bad, but could be better. So let's look at the this one. So now we're going to use the H5PyD client library, and it's going to do the same kind of things, but it's much more concise in syntax. So we import H5PyD, and if I say H5PyD file, a name, and now this is the typical POSIX kind of R or W or A, and the endpoint, I get back the ID. I can get back a data set called /temperature. And if we look down here, we see that dimensions are 1980 by 180 by 360, so quite a large data set. But we're going to pull in just the slice at the first coordinate 16, right? So this is much like NumPy syntax, right? temp represents my data set. Now, recall, at this point, we haven't pulled any data yet from the server. But I say temp, bracket, 16, colon, colon, and now we're telling the server, pull in this slice from the data set. Okay, and now I squeeze it down to a 2D array, and we can plot it. And there we are. I think that's an upside down Earth, if you can screen that. Something else real quickly is I added PyTables functionality as well. So this is something that's not part of H5Py, but here I'm opening a data set of stock information. And you see there's 500,000 rows. And I wanted to read just those rows from the data set where this column is AAPL. So I do that. And I get back 2,982 rows. And I can print out the first 5. Okay. So finally, the multiple writer, and I'm just going to walk through this really quickly. This is a method for the workers. They open a file, they get some information about what to do, and they often do it and write to the file. And then this is the driver, creates a new file. This sets up the workers. And now we go tell workers to do stuff. And they're working at it. So as we're talking, these workers are busily sending data to the file managed by the server. And finally, we can do the results. And we know pi is approximately 3.15. Okay, so use some refinement, but that is how it is. All right, so that's the end of the demo. So real quick, let me just go over some of the upcoming stuff with the HDF server. Okay. So web UI, like I mentioned, I think it'd be really cool to be able to view any HDF data through a browser. So this could either be a generic interface or it could be specific interfaces for certain domains. Access control is pretty important if we want to have the server running in an open network. Because otherwise Andrew might go and run deletes on all my files, and that wouldn't be good. A little further along is a scalable server. So this is the idea of having a cluster of servers that can adapt to any amount of load on the network and any size data repository. Okay. And I encourage everyone to try it out. It's on GitHub. I would love people to experiment and let me know what works or doesn't work. Everything you saw today is in GitHub now. The only thing I would caution, the H5PyD is a little fresh, so you might encounter some problems there. All right, so open floor to questions.
We have time for maybe one quick question, if the next speaker wants to make his way forward.
Over here, yes. Right. Yeah. There's two motivations. One, for web UI, you really need to be JSON to work with JavaScript. But there's a HTTP standard for clients and servers to negotiate on the content type. So we can use that. So servers who are not web UIs could say, hey, please send me the data in binary hex or something, right? And then get that transmitted much more efficiently, right? So that's on my feature list to do. All right, okay, thank you, sir.
Let's thank John again.